Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this word problem we're going to use a system of three equations and three unknowns. And the setup here is that we're combining some animal feeds, and if we use the one made from corn, each unit of that feed has 0.25 units of protein, 0.4 units of fat, and 0.3 units of fiber. We have the same kind of breakdown for the meal made from soybeans, or the feed made from soybeans, and also the feed made from cottonseed. And what we want to do is come up with a total mixture that has 35 units of protein, 38 units of fat, and 28 units of fiber. And we need to figure out how much corn, how much soybean, and how much cottonseed feed we need to use to make that happen. Typically, I would like to use C as the variable for the amount of corn. However, there's also cottonseed. Plus, I don't like using the variable S because S can look like a 5. So I'm going to go back to the old standard of X, Y, and Z to stand for corn, soybeans, and cottonseed. We can read the equations across each row. So the first equation comes from here. 0.25 units of protein multiplied by X units of corn plus 0.4 times Y for the soybeans plus 0.2 times Z is supposed to give us 35 units of protein. The second equation for fat is 0.4x plus 0.2y plus 0.3z equals 38. And for fiber, 0.3x plus 0.2y plus 0.1z equals 28. So three equations, three unknowns, we should be able to solve it. Not really happy about working with the decimals, so what we can do, since we have one decimal that goes to two places, I can multiply everything by 100 to clear all three equations of decimal values. So I would rather work with whole numbers if I could, so I'm going to. I'm going to multiply everything by 100. That's going to give me 25x plus 40y. Remember, that 0.4 is really like 0.40. Multiplying by 100 moves the decimal point two places to the right. Plus 20z equals 3,500. Second equation becomes 40x plus 20y plus 30z equals 3,800. Finally, 30x plus 20y plus 10z equals 2,800. And we could go after a couple of different variables here for elimination. Y looks pretty good because I've got two y coefficients that are the same, and they both go into 40, so we could eliminate y pretty easily. If I look at z, the third coefficient 10 goes into both 30 and 20 evenly, so we could get rid of z as well. You just have to pick one and get started. I'm going to get rid of y first. And I can do that by first combining equations 2 and 3. And I'm going to try to conserve some space here. So if I leave equation 2 alone, but I multiply equation 3 by -1, those y terms will have opposite coefficients. So 40x plus 20y plus 30z equals 3,800, and negative 30x minus 20y minus 10z equals negative 2,800. Add the equations together, 10x plus 20z equals 1,000. I can combine equation 1 with equation 3 by multiplying equation 3 by -2. That's going to give me 40y and negative 40y. So I'm going to take equation 1 and -2 times equation 3. So I'm going to copy down equation 1, 25x plus 40y plus 20z equals 3,500. And multiplying equation 3 by negative 2. And by the way, I could have done equation 2 the same way. Negative 2 times equation 3 is negative 60x minus 40y minus 20z equals negative 5,600. This is pretty fortunate here because this time I'm looking to get rid of y, but I'm actually getting rid of z at the same time. This is pretty fortunate. Doesn't happen a lot. 25x minus 60x is negative 35x. On the other side, 3,500 minus 5,600 is negative 2,100. I've got an equation I can solve for x. All I have to do is divide both sides by negative 35. X equals 60. So I know I need 60 units of variable x, that was the corn. I can bring that back to this equation to figure out what z is going to be. And z was the cottonseed. 10 times 60 plus 20z equals 1,000. 10 times 60 is 600. Subtract 600 from both sides. 20z equals 400. Divide by 20. You get z equals 20. So all I need now is y. And I can come back to one of the equations with the decimals is probably the best one to use. But if you don't like working with the decimals, you can take one of the 3 new equations we made that got rid of the decimals. I'm going to use the bottom equation with the decimals. 0.3x plus 0.2y plus 0.1z equals 28. 0.3x plus 0.2y plus 0.1z equals 28. Put in 60 for x. Put in 20 for z. And let's solve for y. 0.3 times 60 is 18 plus 0.2y. 0.1 times 20 is 2. 18 plus 2 is 20. So if I subtract 20 from both sides, I get 0.2y equals 8. Divide by 0.2. And you'll get y equals 40. So x was 60, that's 60 units of corn. Y was 40, so that's 40 units of soybean. And z was 20, so that's 20 units of cottonseed. A lot of times those are given as pounds or kilograms. Here, the book doesn't use any units, they just call them units, so I stuck with the same approach so that when you do the homework in my lab, it'll seem familiar to you. All right, there you go. Hopefully you picked up a few tricks along the way. First, if you want to get rid of the decimals, get rid of the decimals. Multiply through by the same number, same power of 10 on both sides. Second, if you happen to come up with an equation with one variable, then you can get a solution for that and you can start to work backwards to solve the others. All right, that's it for this problem and this section. I will see you when the next section rolls around.